All right, hey guys, I'm gonna do some of the harder examples for the worksheet. But honestly, the worksheet numbers 1 through 16 are all pretty similar. They're all not too bad. The variable that you need to isolate is usually pretty clear. So I'm gonna do one more of those, and then we'll get to the hard ones, which are 17 through 20. They're a bit harder. So let's try to do number 15 together. I just kind of picked a random problem. So this is number 15. Again, when you turn your homework, these can be out of order. I really don't care. We're trying to solve here. We're trying to see where these two lines intersect, if they even do intersect at all. And so here, it's pretty clear of the 4 variable candidates, the one that I want to get by itself is pretty clearly this y. I could get this x over here by itself, but I would have to subtract and divide, too much. I only have to subtract to get this y by itself. So I'm going to take this equation, and I'm going to get the y by itself by subtracting 5x from both sides. I'm going to subtract 5x from both sides. And now I've got y by itself. I just subtracted it. And again, you might say, well, isn't 13 minus 5, isn't that 8? These aren't like terms. So negative 13 minus 5x, they can't be combined. Yeah, it's 5x. So here, now I have the variable I by itself. I'm going to take it and plug it into the other equation. So wherever I see a y, I'm going to sub this in for that. And I do kind of my arrows. You don't have to do the arrows. And we're on our way here. Again, I started with this equation because y was easier to get by itself. Once I did that, I go to the other equation, and then I'm just going to sub in for y. And so here, 6x comes on down, and wherever I see a y, I just subbed in. I know y and negative 13 minus 5x are the same thing, so I can just swap out this y up here for that expression. And you'll notice here, I made this in the notes in the last video, which you can see in the YouTube description, you've done this correctly if you only have one variable remaining. And here I only have x terms. I'm in the business of solving for x. And I made this point also, you use the law of distributive property here. So 6 times negative 13 is negative 78. 6 times negative 5x is negative 30x. We're here. Let's combine like terms on this side. And so these two x terms can be combined. I have positive 6. I have negative 30. I'm going to stick with the underground analogy, even though it's pretty depressing. If I'm 6 feet above ground and then I go down 30 feet, I'm going to be 24 feet underneath ground. God forbid. And then I want to get this by itself. I'm going to add 78 to both sides. My goal here, I'm trying to get the x by itself. And you might say, well, why didn't you do that up here? Why are you doing all this? Because I can't really get the x in terms of whole numbers up here because there's always going to be a second variable. When there's 2 variables in the equation, you just can't solve for one. Here, there's only 1 variable, I can actually solve for it. So I'm going to add 78 to both sides. Negative 6 plus 78 is 72. Divide both sides by negative 24. I got negative 3. So you're going to add 78 to both sides. Divide both sides by negative 24. And then to solve for y here, guys, we take this and plug it into either one you want. Excuse me, I'm going to plug it in the second one just because. So again, in the original, it said 5 times x. Because we know that x is negative 3, I'm going to rewrite it as 5 times negative 3. Add 15 to both sides, and you get 2. Again, 5 times negative 3 is negative 15. Add 15 to both sides, negative 13 plus 15 is 2. All right, so we get our final answer of negative 3, 2, and visually that's the point on the graph where the two lines intersect. That's the idea. All right, we got time, guys. We're gonna do one of the harder examples now, and I'm gonna warn you here, we're gonna get decimals are gonna be kind of among us very soon. A lot of decimals in the next problem. So number 17 here. Again, and I have a timeline here, so pause the video, write this down. I don't want a lot of wait time here. We're trying to get one of the variables by itself. And actually, just pause here. Hopefully you learned last week, it would be much easier if we just used elimination right here, because it would be very easy just to combine these two equations together and then solve. I'm going to be honest here, if you know how to do that, and you should, given that we did it last week, go ahead and do that. But if you want to say, well, how would I use it using substitution? We're going to use substitution here, but this is the point I made last video. A lot of the times, elimination beats substitution. Not always, but a lot of the times it does. So that said, let's try to use substitution here. If you want to use elimination, go for it. I'm just going to show in case you want to use substitution. I need to get one of these 4 variables by itself. Unfortunately, I don't have a great candidate to do that. I'm going to choose this variable right here. Actually, this one, you don't have decimals. But anyways, I'm going to try to get this x by itself. You might say, how'd you know to do that one? Well, this one's negative. This one's negative. I'm just going to choose this x. So I'm getting this x by itself. I'm going to minus 3y to both sides. I'm going to divide by 3. Work here. So again, I'm trying to get this x by itself, so I minus 3y to both sides. Then I just have a 3x, so I divide both sides by 3. Negative 3 divided by 3 is negative 1. Negative 3y divided by 3 is negative y. Now that x is successfully isolated, I'm going to plug it into the other equation, which means this top guy, and then solve for the other variable, which would be y in this case. So I'm going to take this, I'm going to sub it into this top equation. So in the top equation, you'll note it says negative 3x minus 4y. So it's going to be negative 3 times negative 1 minus y. That's the idea. So again, wherever I see an x in this top equation, I just remove the x and I substitute it in this guy. And then once again, we use distributive property. So negative 3 times negative 1 is 3. Negative 3 times y is positive 3y. That. So here, guys, we just got to combine my terms. 3y take away 4y is negative 1y. And I'm going to try to get this negative y by itself. Well, I'm going to go ahead and, this is positive 3. I'm going to get to the other side by minusing 3 to both sides. 2 minus 3 is negative 1. And pretty clearly here, guys, negative y equals negative 1. Well, y has to be 1 because negative 1 would equal negative 1. If you want to divide both sides by negative 1, that's fine. But hopefully at this point you can just recognize that y has to be 1 because negative 1 would equal negative 1. And then to solve for x, we just plug it in at either of the top ones. Because this one down here has no negatives, I'm going to choose that one. So again, I chose this equation. Wherever I saw a y, I subbed in a 1. So over here was y. Now here is 1. 3 times 1 is 3. And I'm just trying to get this x by itself. So I'm going to minus 3 to both sides because this is positive 3. We always do the opposite operation. And so I have 3x, negative 3 minus 3 is negative 6. So divide both sides by 3. And I got x to be negative 2. Negative 2. So my final answer is negative 2, 1. And again, visually, that's where the graphs intersect. So I'm probably not going to do none of the harder ones. Just kind of fight through it. If you need to use elimination, you can do elimination. Try your best on them. If you really need it, ask me, but I'll do another one. But I just didn't want to do 3 videos for this one topic. So anyways, guys, your homework is numbers 1 through 20. 20 total problems, but I did 4 of them for you, so only 16 problems. I'd like that by Friday. I also assigned con for this week on graphing lines. You might say, wow, con and this. The con, most of the con is not too bad. I'm going to post a video shortly to help on one of the cons, just to provide notes because it's been a while since we did one of them, but it really shouldn't be too bad. So almost over here, guys. Hang in there, and I will see you in another video. Take care.